Hey guys, Dr. Callahan here. Welcome to week 3, Tuesday of AP Calculus AB. Here are your 3 questions for the warm-up. You might want to pause the video to get started. Question number 1, do you feel like the school year is better or worse or the same as previous years? Why? I know how I feel about this year. This has been a very unique year. If you can go to another high school, which one will you choose and justify your response? And the last one is, are these 3 functions, are they even, odd, or neither? I have the steps right there for you. The question asks you to please explain why the 3 examples are even, odd, or neither. Okay, let's go ahead and take a look at this. Now, remember, if the function is going to be even, when you replace the x with a negative x right here, it should give you the original equation. Now, on the other hand, when you replace the x with a negative and it gives you the opposite of the y function, it is going to be odd. So looking at this, let's go ahead and do that. Let's replace the x with a negative x. So I have 3 times negative x squared plus 8. Now remember, whenever you have a negative number, if the exponent is odd, like for example 3, 9, 13, your answer is going to be a negative. Now if you have a negative number and the power is even, like 2, 4, 6, it is going to be a positive number. So looking at this, because it is even, you're going to have a positive 3x squared plus 8. Now, as I'm looking at this, is this the original equation? And the answer is, yep, it is. So I know that it's going to be even. Because when I replace the x with a negative x, I did have the original f of x equation, which was 3x squared plus 8. So good job. Next one, let's take a look at this here. Let's replace it. Negative x to the 5th power minus 4 times negative x. Now, this one is odd, and because it's odd, your overall answer is going to be a negative x to the 5th power. Negative times a negative is a positive 4x, and so I'm going to take this and see. Is this the original? No, it's not. It's kind of like opposite signs. So then I ask myself, if it's not the original, is it going to be a negative y value or a negative f of x? Well, it would be, because if I have x to the 5th minus 4x, and then I timed it by a negative, it will give me a negative x to the 5th positive 4x, which in turn would match what I have. So I would say it is odd because when I replace the x in f of x with a negative x, it resulted with a negative f of x, which is negative x to the 5th plus 4x. So check. All right, last one. So with this equation, let's go ahead and replace the x with a negative x. I have 2x, or negative 2x squared. Actually, I'm going to get rid of that. Minus negative x minus 1. So let's go ahead and simplify this. That is an even exponent, so I know my answer is positive. So it's going to be a positive 2x squared. Double negative makes it a positive x minus 1. So the easiest one to do is first compare this to the original equation. Is the same? Nope. So I know it is not even. Okay. So then I ask myself, well, could it be odd? And if it's odd, your f of x will equal to the negative f of x. So if I have a negative f of x, everything here will become the opposite sign. So my positive 2x squared will be a negative 2x squared. Negative x becomes a positive x. Negative 1 becomes a positive 1. Now, does that match? Nope, it's not odd. So in which case, at this point, if it's not even and it's not odd, you can say that this function is neither. Why? Because when I replace f of x with a negative x, it is not equal to the original equation and is not equal to a negative f of x. So therefore, it's neither. All right, if you're currently still experiencing difficulty logging onto Math Excel, I made a little video on how you can go about the easy way of logging onto Math Excel. You just simply go to a Google search engine, type in Washoe County School District Math Excel, click on it, and type in your traditional like computer desktop login, and then you will be able to access that. So there's a 3-minute video on that. If you need some assistance, here's a link on that. Or you could just go to my YouTube channel, and I do have that link to it. All right, let's go ahead and get started with today's stuff. Okay, so last time I saw you guys, we talked about the practicing of the assignments that you were supposed to cut out. And there were a few cards that you had that you were supposed to practice with. So here are my answers for the first card, and you can pause it. Here are my answers for the piecewise function card, for the difference quotient card, for the domain and range, for the transformation, for graphing piecewise functions, even asymmetry. I'm going to go ahead and go over this one with you guys. For A, it says f of x equals 2x plus 1. Find that crazy thing, which will help us when we eventually get to limits, which, interesting enough, is actually today. Okay, so as I'm looking at this, if f of x equals 2x plus 1, I need to go ahead and figure out what f of x plus h is going to be, which means every time you see an x, you're going to replace that x with x plus h. And so if I distribute this, I will get 2x plus 2h plus 1. Now, negative f of x, which we just learned from the even and odd, you're just going to switch the signs. So positive becomes a negative 2x, positive 1 becomes a negative 1. Now that I have these parts of this, I can now substitute it in here and simplify my equation. So it says find f of x plus h. That's going to be 2x plus 2h plus 1 minus f of x. Well, minus f of x is just negative 2x minus 1 all the way over h. So now I can go ahead and try to simplify this. Let's see what I can cancel. I can cancel the 2x with a negative 2x, positive 1 with a negative 1, boom, 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 gone. So now I'm left with 2h over h, and I can actually cancel the h. So my answer is just going to be 2. Let's try that same thing with the next one for b. So this one was a, and here's b. So I have g of x plus h. So here I have a trinomial. Anytime I see an x, I'm going to replace it with an x plus h. Don't forget the square, like I did. Now this one, you won't unfortunately have the FOIL, and it's going to take a little bit of time to simplify. But if you FOIL this, FOIL, first you have x plus h, because there's a square. So first is going to be x times x, which is x squared. Outer is x times h, which is xh. Inner, which is h times x, is also xh. I should put them in alphabetical order, so let's go ahead and do that. hx, there we go. And then last, h times h, which is h squared. Combine your like terms, you're going to have 2hx. So now that I have these components to the FOIL, I can go ahead and rewrite that. So this piece right here would just be x squared plus 2hx plus h squared. Next, I need to go ahead and distribute the negative 3 into the binomial in parentheses, negative 3x minus 3h, and then don't forget your plus 5. So all of that was just for g of x plus h. Let's see if there's anything that I can cancel, and unfortunately there is nothing that I can do there, but that's okay. Next I have a negative g of x. So I'm just going to automatically transform this. So I'm just going to continue with this on minus x squared positive 3x minus 5, and this beautiful thing is all the way over h, so don't forget the h. So now I can go ahead and spend a little bit of time canceling a few things. Negative x squared and positive x squared gets canceled. I can get rid of my positive 3x and negative 3x. That gets canceled. And I can also get rid of my positive 5 and my negative 5. And I think that is it. So boom, 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 done. And then what I have left is 2hx plus h squared minus 3h all the way over h. Now you can go ahead and factor out an h because they all have it. So I have 2x plus h minus 3. So then my h's cancel, and I am left with 2x plus h minus 3. And that is your answer. And that concludes the activity that you guys have to do with the last one. All right, so today we're actually going to start calculus with introduction to limits, limits that fail to exist, first method of finding limits using a graph, second method of finding limits using a table, and then eventually we'll do the third method, which is analytically using algebra to find limits. I do have a group work part, practice, and work on 3 examples. There is a quizzes link, which is right here. They're going to type in, and you can practice that with finding limits graphically. So let's take a look at your guided notes. If you go to your guided notes, today is week 3, Tuesday, and I always label them. Here are some extra ones that you can practice if you would like some more additional challenges. I also went ahead and typed up my notes for you guys, so you guys can go ahead and take a look at that. This is going to be your notes in class. This is my notes on summarizing today's lesson. And your group work practice problem is going to be right here. There are 3 examples. If you do however need another video, I have a Vimeo right here that's going to go over a few things, and then your exit ticket. All right, so let's go ahead and get started with limits. Okay, so here's the limit. X cannot equal 1. Why is that? Because if x equals 1, on the bottom here in the denominator, you have 1 minus 1, which will give you 0, and you cannot have 0 in the bottom of this. So does that mean that this limit does not exist because you have a 0 in the denominator, which is undefined? No, you have to be a little bit savvy with how you're going to approach this. So instead of saying it is going to result in a 0 of x equals 1, what if I challenge you to think about as x is approaching from the left side of the graph of 1, so here is 1, and let's say I am approaching this 1 from the left side of the graph, okay, which is going to be like 0.999. Would that make a difference? Or if instead of making approaching it from the left side, what if I approach from the right side of the graph? So as x approaches 1.0111, would that be possible? And if so, if I were to go ahead and plug these 2 numbers in to this function, so for f of 0.999 and f of 1.0111, would that result in undefined, or would it actually give me a concrete answer? So think about that. If I were to go ahead and graph that limit, this is what my graph will look like. Yes, at 1, it is empty, okay? But as you approach it from the left side, which what I said was 0.999, you can see that the limit as f of 0.999. The y value is kind of approaching to 3, I would say. And then similarly, if you were approaching this limit from the right side of the graph, so it's not equal to 1, but it's approaching from the right side, so at f1.0111, you can see that it's kind of approaching a 3 as well. And given the fact that both of these were consistent at 3, I can go ahead and say that as x approaches 1, my answer to this limit is going to be 3. So the first way of finding the limit is with a graph. You can graph it and visually see where it is. The second way of doing this is with the table of values. So here we go. Here is 1. It is going to be doesn't exist, obviously, but if I approach it from the left side, I can start off with 0.75, which is a little farther than 1, but I can get closer to 0.9, to 0.99, to 0.9999, and as you guys can see here, the y value slowly creeps up closer and closer to 3. Similarly, if I were to approach the function from the right side, so instead of being at 1, I can say, well, what if I approach it from 1.25, which is a little far, but it's getting closer, 1.1, 1.01, 1.0001, etc. What do you see the pattern here? It is the y value getting closer and closer to 3. And given the fact that both of these values on left and right side are approaching 3, then I can say definitively that as x approaches 1, my answer to this limit, my y value, will be approaching 3. Here's a new limit. I have x over square root of x plus 1 minus 1 as x approaches 0. You can go ahead and pause the video and try to graph this on Desmos. Once I graph this, this is what it looks like. So you can see that when x approaches 0, it is not valid. Okay, so let's try seeing this from the left side and the right side. If I approach 0, let's say at negative 0.00001, then I can say that it looks like it's about y equals 2, right there. And if I were to approach it from the right side, maybe at 0.00001, then I can say that it's around 1 or 2 as well for the y value. So then let's go ahead and confirm this using a table content. So as x approaches from the left side, you have negative 0.01, negative 0.001, negative 0.00001. So it's getting closer and closer to 0. Here are my y values. And they're getting closer to 2, okay, climbing up higher. Now, on the other hand, if I were to approach it from the right side, so I could start off with 0.01, then 0.0001, 0001. As I get closer and closer to 0, let's take a look at the values. And as you can see, it is getting closer and closer to 2. So then is it consistent from the left side and the right side that as x approaches 0, it's getting to 2? Yes, it is. So these are the 3 different types of methods that you can use to find limits through the numerical one, which is by table, graphical, which is by technology, so Desmos or TI-84, and the last one is analytical, which is using algebra to manipulate the equation, so that way you do not result in an undefined. So we'll go over that next time. Okay, these are the 3 limits that will fail to exist. So the first one is behavior that differs from left to right. Second one is unbounded behavior. And the third one is oscillating behavior. So these are the 3 of the limits that will fail to exist. So let's see some examples. So with this one, These are the three. Identify the three limits that fail to exist. Match them to the graph. Okay, so from before, I can see that as I am approaching from the left side, my limit goes to negative infinity. As I'm approaching the limit from the right side to 0, it goes to positive infinity. So with this one, out of the three that we went over, it is a behavior that differs from right to left. Second one, if you take a look at this one here, as I'm approaching the 0, so as I'm getting closer to 0, you see how it jumps up to 1, so my y value is 1. But as I get even closer to 0, it all of a sudden plunges down to -1, and it kind of continues in this pattern. And therefore, this one is going to be oscillating behavior because it is going up and down, up and down. Oh, you know what? I kind of messed this up. I'm sorry. So, okay, so this one here is oscillating behavior. Okay, your limit does not exist because of oscillating behavior. Third one is as x approaches to 0, your answer here is -1, but as x approaches the 0, from the right side, your answer is +1. So this one, the limit does not exist because of different behavior from left to right, okay? Now with this one, as x approaches to 0 from the left side, we put a little negative there, your f of x is going to be equal to negative infinity. However, as x approaches 0 from the right side, right here, your f of x is going to be positive infinity. So obviously two different behaviors. So with this one, it is going to be unbounded behavior. So the limit does not exist because of unbounded behavior. And a lot of time with the oscillating behavior, if you look at example 5, it's generally with a trig function, like sine 1 over x. If you were to go ahead and graph this and then zoom in on it, this is what it will look like. So whenever you have a trig function, just remember that limit might not exist because of oscillating behavior. All right, so that basically summarizes what we're doing today. If you would like some additional practices, you can go to your guided notes in week 3 Tuesday, because I do have some additional practices here from the textbook. You have access to this because I made copies of it as well. There are several questions here, so make sure you guys answer them. In addition to that, this is the extra practice from your textbook. I want you guys to turn over to the 3rd page. And if you take a look over here, this is a summary of what we discussed in class. And I would like you to go ahead and focus on these 3 examples here for your classwork. And I will go over these answers with you next class. All right, have a good day, and I'll see you guys next time.